That is good.
Okay, today we are doing section 2-4, which is chain rule, and we're gonna play a quick round of guess that derivative, right? So, all right, y equals 3x minus 2 to the 5th. I want you guys in your groups to take 1 minute and see if you can guess that derivative.
Are you staring through the
I was checking to make sure that the example was showing up on film. Okay, so take a minute.
It's like 15.
See if you can guess that derivative.
15 minus 0.
No,
15 to the 4th.
I know, but it's like that. I think it's
No,
what's 3 times what's 3?
Yeah, but when you multiply by you multiply over you know how you multiply by 5 times 4 because you know when you multiply you multiply 5 it's 5 minus 2. Give me 15 next to the 4 because it's 2. That's what it is. We multiply binomials. We multiply
times 5 to the x.
I think we're about to learn about this.
We do it like that.
It's chain rule.
Okay, so what kind of answers did we get in any group?
5 to the 4th.
5 to the
No, 15.
4th.
15 to the 4th.
Whoa, 15 to the 4th.
Yeah, we got that. That's,
Okay,
we're locking it in. Final answer.
No, we didn't.
you got 15 to the 4th
Hey, look, it's Hannah
also?
Davis.
Wow, she said yes to school.
Oh, come on in, have a seat. Okay, anything else? No one got anything different?
No, that's the only right answer.
We got
What did you guys get?
5 and then parentheses 3x minus 2.
Alright, well.
Okay. Now, do you guys know how they got 15 to the 4th? They did 5 times 3 and then put the whole thing to the 4th? Like that?
I feel like that's too easy.
Yes.
Now, if along that line, algebraically, I would have thought you would have had 5 times 3 to the 4th like that,
That's what we were thinking.
right? Because this and this are not equivalent, right? Okay, okay. Any other answers? Because so far the correct answer is not up there. Any others? Yeah.
Would it be 15x to the 4th? Because if you, like, the negative 2 to the 5th would be, like, kind of irrelevant.
This is 15x to the 4th. Oh, 15x to the 4th.
Yes. 'Cause,
Yeah.
like, we don't have an
Ooh,
x.
that's a new one. Okay. Now, is the 15, is it quantity 15x or just 15 times x to the 4th?
There's a difference.
Is the 15 also being raised to the 4th?
The 3, no, it was like the 5 times 3 is no.
No? Okay. Yes, Ryan.
5 parentheses 3x minus 6 parentheses and parentheses to the 4th.
3x minus 6?
Wait, it would
Okay. You want to tell me how you got that?
So I found the derivative of the original parentheses.
Okay.
So when you have 3x minus 2, if you were to just square that, then you would end up you would end up getting 9x squared, and so your first term and your second term of the polynomial would be the derivative, and then I put it to the 4th and then simplify it.
Okay. That's an interesting approach.
I don't think that's right.
Okay. All right.
Gonna go out on a limb, say 243.
243. Can you tell me how you got that?
Well, because 3x minus 2 to the 5th is 3x minus 2 times, like 5 times. And so if you do the derivative individually, then it's just 3, so 3,
Ooh, 3 to the 5th.
yes.
Ooh, that's a very interesting approach. Okay, good. Any others? Wow, another one? You've already guessed
No.
one.
I think we
I want to correct it. I was thinking that, wouldn't it be you would raise you would do 3 raised to the 5th times 5x to the 4th.
That's my favorite cough.
Let's put
Probably
them
get that
away.
checked out by a
Put
doctor.
them away right now before they get taken. Okay, all right, these are fantastic guesses, and then you know what? They show a lot of really good, serious mathematical thoughts,
Especially ours.
especially yours, but unfortunately none of them is correct. Oh, no,
I
that's
should've
okay.
guessed.
Guess that derivative is really just meant to be a guess. It's just meant for you guys to kind of push your brains a little bit, see if you can figure something out. All right, here's the correct answer.
See, that's what I thought it was.
I haven't even written it yet.
Oh, I thought you. As I suspected. Oh, okay, she's not done yet.
Okay.
Oh.
Wow.
Oh.
Whoa.
Oh.
Oh.
Okay.
So I was kind of right.
So,
Oh.
actually, Andrew's group really was probably the closest. Yeah, so,
Why would you back us up?
so sorry. Yeah. You had a 15 though,
We did.
right? That's true. So that's good.
And
All
the
right,
4, yeah.
and a 4. Now, the way the chain rule works, and we're going to walk through this after learning the rule too, but the way the chain rule works is when you have an argument of a function. Do y'all know argument of a function is like the input of the function, the stuff you're plugging into the function. We call that the argument, okay? Okay, so when your argument of your function is something other than just x, like so far you've just been doing x to the 5th, right? Now you don't have just x to the 5th, you have the quantity 3x minus 2 to the 5th. When your argument is no longer just x, you still do the same kind of derivative. You still multiply by the exponent and reduce it by 1. That argument never changes. But we have to take into account that it's not just x. So where do you think that 3, where does that 3 come from?
The 3x.
It's the derivative of the argument. Okay? So you do it's kind of an outside-in thing. When I'm thinking of these problems, I kind of cover up the input and I just do the outer derivative first. So 5 times whatever's in here to the 4th. And then I multiply by the derivative of the stuff inside, right? That's chain rule. You've actually been doing chain rule all along. You just haven't been thinking about it as chain rule. If you did y equals x to the 5th, and you did your y prime, what's the derivative of x to the 5th? 5x to the 4th, right? Well, if I thought of y as x to the 5th and applied chain rule, I would get 5, my input stays the same, times the derivative, which is 1. Right? Okay, so chain rule, welcome back. Chain rule is something that actually gets applied to every derivative in the entire world, but we don't really think about it that much unless our input is something other than x. Now, I'm about to actually write what the rule is. And you have to know this rule. So, you know product rule. F prime g minus f g prime, right? You know quotient rule, f prime g plus f g prime, sorry for product rule. Quotient rule, f prime g minus f g prime over g squared. So you know product rule, you know quotient rule. You have to know chain rule. For some reason, no one remembers the actual rule. People just remember how to do it. You have to know the rule. You have to actually know it with the f's and the g's and stuff. So I'm going to make you memorize chain rule. And I'm going to get a better marker. Okay, chain rule says that the derivative of f of g of x So we're talking about a composition of functions, when you're plugging one function into another function. So, chain rule, the derivative of f of g of x is f prime of g of x times g prime of x.
Easy peasy lemon squeezy.
Easy peasy? Okay. Well then, for our first function that we did today, going back to that same example, if I write f of g of x is 3x minus 2 to the 5th, I want you guys to take a second. Let's see how comfortable you are with composition. In your groups, take a minute, see if you can figure out what is f and what is g. If f of g of x equals 3x minus 2 to the 5th, see if you can figure out what is f and what is g. What is being plugged into what? Alright, so in your groups, take a moment. Figure it out.
Take away G of X.
When you plug in one equation to another, you plug in x.
Wait, what do you think it is?
How long is this time? Do you have enough time to fill up the water bottle or should I wait?
Oh, go right.
You don't have to flag down the hallway and stuff.
Replace that with parentheses. It's not working the way I thought.
Alright guys, what'd you get? What's f of x?
X to the 5th.
Very good.
Maybe that was just happening.
And then what's g of x?
3x minus 2.
Good. Because, it's okay. You're taking this is like your inside function. This is, see how it's inside here? This is what you're plugging in to this.
Right.
Right? You're replacing the x in the outer function with this. So for a plain function, your normal input variable is just x. When you have a composition, now your input becomes another function, right? That new function is the g. That's what you're plugging in. Okay, so chain rule. The derivative of f of g of x is f prime of g of x. It means you do that outside derivative first, keep the input, the argument the same, times the derivative of the argument, the stuff that's inside. Alright, so let's do a few examples and see how we do. Make sure this gets on the camera. Okay. So, first we're going to have some fun. We're going to find all values of x for which f of x equals the cube root of x squared minus 1 squared has a derivative that is either 0 or undefined. This concept will come in handy when we get into applications, knowing where a derivative is either 0 or undefined. So we have the function f of x equals the cube root of the quantity x squared minus 1 squared. And we want to know where that derivative is either equal to 0 or undefined. Now in order to find the derivative, you're first going to probably need to rewrite the function, right? So I want you guys to take a minute in your groups. I want you to rewrite this function with an exponent instead of a radical, find the derivative, and then rewrite it back in radical form. take a minute.
X squared minus 1, right?
Damn,
Make sure you're working together.
Was that a?
Same theory.
Bro, no,
Just like X squared, so it'd be 2/3.
JP doesn't know what he's talking about. I think JP just doesn't study.
Would it be?
I don't think you guys study for.
Okay, so it would be 1. So
I spend like an hour studying every turn night.
That's it, or
I gotta get my caps ranked.
like the first three are good.
I always memorize the study guide instead.
I didn't remember. You might think on them, boy. I don't like look up colleges. Did you do early admission and say? You're right. Remember the action? Is this right? What I did when I took that to that, is that right? That's right, right, bro? That was got right. So I just wanted to get something that's right or wrong.
I just need most to say.
How are you gonna come with the yes and the no? Well, actually, yeah, it's right.
Wait, do you need to turn your recommendation letters?
Did you get 2x times parentheses x squared?
You have to cover your words.
I don't really have to.
If I get in,
We're doing the stars problem.
Just so, if I get in the second,
Nutella.
you gotta pay attention. That's just pure carbohydrates.
Yeah, but it's so good.
No, there's protein in Nutella.
There's peanut butter in there, so it's not.
Nutella, is it? No, it's like.
It's hazelnut peanut
Yeah, I
butter.
was just saying, I heard about that.
But hazelnuts do have a lot of protein.
Did they already get in trouble?
It's the only source of protein.
Those are better for you, peanut butter.
You buy that roll from Costco?
No, I bought it from
Are you sure?
Alright,
Those rolls from Costco.
so first things first. Quiet down. How would we rewrite the function? F of x is what to the what?
X to the 2/3. Alright, never mind.
x squared minus
X squared minus 1
to this 2,
to the 2
and then like parentheses. Oh, 2/3.
2/3.
I was gonna do parentheses.
Alright, did everyone rewrite the function correctly? Right power? Okay, so now to do the derivative, what do we get? Someone speak out, it's okay.
2/3 to the x.
2/3 to the x.
2/3 times x. Sorry.
2/3 times x. Ah, we have a difference of opinion.
I had an x on the outside. Like
X on the outside.
Because then when you the derivative of the inside is no, never mind.
What is
Don't even talk to me. Just don't listen to me. I didn't see the square.
Alright, let me ask you guys. When we take the derivative, does the argument change? No. So what's in here has to stay x squared minus 1. And then what's the new exponent? Negative 1/3. Then I multiply by the derivative of what's inside, which is 2x.
Yeah, that's where I messed up.
Okay.
I thought the derivative from the inside was x,
Ah,
not 2x. I forgot the 2.
forgot the 2. Good. Are there questions just on this step?
We'll be. Never mind.
Y'all okay with that? Everyone in the back? Okay. So now to rewrite. Here's the trick. The trick on the last quiz for that first problem. Most of you did great on the quiz. They were good grades overall.
Hundreds.
There were perfect scores, sure. The first problem, the derivatives didn't get you. It was rewriting back in radical form that got you for several people. So anyway, I'm just going to point to a thing, and you tell me if it's going to go on the top or on the bottom of our final answer. There's 2 over here. There's 3. This term. Bottom. Top. Do you all understand that? Okay, so top, 2 times 2x, what's going on top? 4x. 3 times what root?
Cube root.
Cube root of x squared minus 1 to the first, right?
Alright.
How'd you guys do on rewriting back? Get some good thumbs ups. Any thumbs downs? Any questions?
So if you use the quiz right now, you only get 100, is that what you're telling me?
I mean, you didn't raise your hand, so.
Yeah, that's always, the 3 will always go down.
I bet you would say.
Well, if there's a denominator of a fraction, then it's gonna be on the bottom, yeah. Yes.
Well, yeah.
Good. Other questions? Okay. Now, this is our derivative, but the question said, find the values of x where the derivative is 0 and where the derivative is undefined. So first, I'm going to say where f prime equals 0. So to find where the derivative is 0, do I set the top equal to 0 or the bottom equal to 0? I set the top. So our derivative is 0 at x equals 0. To find where the derivative is undefined, ooh, who said that?
You socked it.
Fantastic. Okay, so I set the bottom equal to 0. To solve this, divide by 3, cube both sides, you end up with x squared minus 1 equals 0, and x is plus or minus 1.
Derivatives are easier than
Okay?
units. You know what I'm saying?
Did you guys, are you excited that you got that answer? You guys seem so happy.
I said that,
Oh.
and I doubted myself. But I
Oh.
got it right.
Don't doubt yourself
Oh,
ever.
don't doubt yourself. Yeah, confidence. Confidence. All right. Um,
Alright, give me my thumbs up.
oh, I know my question. The original function, this original function right here, this is a cube root.
Oh, this ain't cool.
Is a cube root ever undefined?
No.
No, really. I mean, unless there's a denominator, right? But where there's no denominator here, so there's never division by 0. So is this cube root? So this function is always what? It's always continuous. So the function is always continuous. How can we have two spots where the derivative doesn't exist?
It's no slope, it's just.
So vertical tangent. So one possibility is we have a vertical tangent. What's the other possibility for a derivative not to exist?
It's not the same.
Sharp turn, right?
No crazy oscillations.
No, that's for limits.
I know.
Alright,
Okay.
give me- give me my-
All right. The graph of this function, whenever you have a 2/3 exponent, you're going to have a sharp turn. Okay. All right. So whenever you have a 2/3 exponent, you get a sharp turn. This one's extra fun because you have a quadratic inside, so you get two sharp turns. So you end up with something that looks like that, right? So it's undefined here and here at plus or minus 1, and then at 0, we get that nice horizontal tangent, right? So we have a derivative of 0, we got a nice horizontal tangent, and then undefined at the sharp turns. Does that make sense? Okay, good. All right, let's do another one.
Yo, bro. Let me put my leg in a minute.
Okay. Okay. Okay, you phone now, so quit asking me. I'm getting $2 grand playing football. Look at this.
All right, so
So
let's
smart.
do a tangent line.
What?
All right, find the equation of the line tangent to,
Yeah,
What?
y equals 4 over, how about 2t plus 4 squared at x equals -3.
So.
Now I have a little bit of advice from Price to give you today. All right, so before you start tackling this problem, just hear my voice for a moment. When you have, if you are given a function and you have something with x's over something with x's, so you have function variables over variables, then you should always do quotient rule, all right? I know that you can rewrite this like this, and do product rule, and you may think that's easier. Product rule is not easier. It may be easier to do the actual derivative, but then what's going to happen is you're going to have two separate denominators. You're going to have to find an LCD and you're going to have to combine, and the simplifying really gets you. So when you have variables over variables, don't switch and do product rule. Keep it as a quotient rule. Because quotient rule, you're automatically over one denominator. So it kind of simplifies itself for you. It's easier. So if you have variables over variables, do quotient rule. But if you have variables over a number, well, if you have variables over a number, then just make the number a coefficient, right? Okay? So don't do quotient rule on that. Or if you have number over variable, then it's honestly easier to just rewrite and just do regular old chain rule. So variable over number over variable, those I don't do quotient. You can do quotient rule. If you do quotient rule on this, just remember the derivative of the top is 0. Put the 0 in, don't leave it blank, put the 0 down, because otherwise you'll forget about the negative and then you mess it up. Right? So if you're going to do quotient rule, that's fine, just make sure you write the 0 where it goes. So anyway, but for this one, personally, if I were doing this problem, I would rewrite this with what exponent?
-2.
The -2. I would rewrite it with the -2. Alright, so I want you guys to take a minute in your groups. What 2 things do you need for equation of a line?
Oh, you know the slope.
Slope and a point, right? Where do you find the point?
Plug in the number.
Into where?
Into your y.
The original function. Where do you get the slope?
You do the derivative.
You plug it to the derivative. Go ahead and do it.
Do it.
All of you.
My bad.
Yeah, Mustafa.
See, ST will need it. I need to make sure the decimals. 2 squared plus 4 2t plus 4 squared. Got you guys. Hey Jacob.
Would it be term 2 or term 3? I have that. Well, I just got -20.
Yeah. And you get -6 plus 4.
Actually, I did do -8. I squared it plus -4.
-2 squared is positive.
It's 4 over 4, which is.
Then when it's just multiplied by the 4 out here, then you get 16, right? Maybe 3 times 2.
All you're doing when you're plugging in the x into the original equation is finding the y coordinate.
Yeah, that's what it is.
Yes. The one that you're getting.
Whoops. Wow, glad I made that mistake here, not on the test.
Because 2 over 1 minus 3.
Oh no, it's a -3.
Do you also have like a separate lunch?
No.
Oh, this is your lunch.
I don't like eating in the cafeteria. It stresses me out.
All that.
And then you find the
Yeah, because there's so many people around me eating, and it just like stresses me out talking and eating at the same time. I don't like it, so I like eating.
You do that like you're in
Yeah, but it's not the same. It's like a small group. Like in last year, I would always eat in the 4th period class, Miss Kelly's class. I would just sit there in the back of the room and just eat my entire lunch.
That's what I do next year.
Or you. But next period, I have PE, so I can't really be like running and eating my lunch at the same time. So you gotta do it in the period.
Okay. Alright, so for our points,
Yeah, that's towards the end of the year when I got to know this.
I'll start you off. The x value is -3. So, where do we plug in to get the y? Original function. So we get 4 over, well, let's see, that's -6 plus 4, -2 squared Why, it's 4 over 4, which is 1. Did you all get that?
Yeah.
Good. Alright, so now we need to find the derivative.
Use the chain rule.
Walk me through. I need someone to walk me through. Oh, I've got that right here. Awesome. Okay, so what do I do next? Negative 8. What's the argument? 2t plus 4 to the negative third. Am I done? Times 2. Beautiful. Okay, so now if I wanted to rewrite this, tell me, top or bottom? Top. Top. So this is going to be negative 16 over 2t plus 4 to the third. Now, if I were to write my equation, y minus 1 equals blank times x plus 3. So in here is, would I put negative 16 over 2t plus 4 to the third? No? Well then what do I do? Plug the negative 3 into my derivative. I need y prime of negative 3. So I get negative 16 over, let's see, negative 6 plus 4, negative 2 cubed. What is that? Negative 8. Oh, so my slope is just 2?
Yep.
Hey, that's nice. Any questions on that one? Okay, we're going to take it up a little notch.
Even harder?
No, not harder, just different. The next problem, I'm going to put 2 graphs up on the board.
Yeah, wild
All right.
From like a long time ago.
Who's wild
But you guys were messing with it?
Here's my instructions to you. This is f, this is g. H is f of g of x. You are not allowed to find the equations of the lines for f or g. Alright?
Oh, you gotta be so rude.
Okay? So no equation finding. Instead, you have to find h prime of 3. Now h is f of g of x. In order to find h prime of 3, I first have to find
G prime.
h prime of x. Using, hey, what rule could I use?
Chain rule.
Chain rule. It's right there. Right?
Great.
Right.
Good. So I want you guys to find h prime of x, then write out what h prime of 3 would be, and then see if you can figure it out from the information on the 2 graphs. In your groups, go.
They just find the slope, bro. Alright. So, what's the slope of f? F slope seems to be, rise over rise. So, it rises like, no, f? Correct. I know.
Slope is rise.
F is 2. It rises 1, 2, 3, 4, 5. It rises 5. No, it rises 4. Yeah, so it's 2. So 2. And then the equation for the other, don't we need the equation for the other one? That's -1. Yeah, but like, we also need the equation for the thing.
Actually, one.
We just need the g of x equation.
2 times f of x, which is negative x.
Yeah.
2 times negative x.
Times -1, so we have to just do -2 to x, to negative x. Right?
Why would it be like 2x?
It would be, wait, no, -2 to the x, negative x. Yeah, so that's the derivative, which is
Well, write out.
h, right?
Nope. Nope, we use the equation. So first you have
So
to,
then when you plug in 3,
and we want h prime of x. So we need the root of that. So just to run through that problem, see the top line in red. So what is h prime of x?
so you guys basically just got my phone.
No, you guys should something.
My phone was out here.
It was your fault for having
not
that.
doing nothing, and then you guys come
It
over
wasn't
here
just something wild thing.
from like an hour ago,
Write that
Why are
out.
you blue dotting wild thing?
and then it was right here. It's my dog.
Your dog.
It's my female dog. But anyway, it's just sitting there, and then you guys happen to go pick it up, and then it happened to get taken away.
Yeah, she just came over.
After you guys have been playing with
You
it.
can find the
like,
slope, you're gonna need the slope.
yeah, it was just since that you were
Yeah, you can
playing
find the
with it,
slope,
I'm like,
but you're not allowed to find the equation. Alright, I'm gonna give you a little start. There are some groups that need a little head start. So remember, if H equals f of g of x, then H prime of x, this is straight definition chain rule, right?
Right. F
So-
prime of g of x
F
times
prime
g.
of g of x
So we did have to find the equation of one of the lines.
times, nope,
G prime.
g prime of x, right?
Did we have to find g of x?
What are we looking for?
H prime of
Oh, you're so
H prime of 3. So H prime of 3 is f prime of g of 3 times g prime of 3.
Oh, we made it a slightly.
You made it what?
We made it slightly more complicated.
Ah.
Oh, silly me.
What is g of 3? It's negative 3.
Dang it, now.
Why you gotta shut up?
Okay, now here's the thing. We need f prime of negative 3. Now this is a linear function. So f prime is the same anywhere in the function because what is f prime in one word the same as? It's the slope, right? So we're just talking about the slope of this line. So we go up 4 over 2. What's the slope? 2. It's 2 anywhere. Does that make sense? So f prime of negative 3 is 2. G prime of 3 is the slope of this line, which is negative 1. So what's our answer? Negative 2. You got that?
No.
Raise your hand if you got it.
Raise your hand. Stop.
Almost got it?
I'm so bad. I see you the two lines down there. Did I?